Hello there everybody, I'm SuperDavo001 and welcome to my first video in a while. I apologise for that, it's reasons of GCSEs and stuff like that. So in this series I'm going to be showing you how to use OpenGL. So this is a program I made earlier, just so you know. Hold on, let me just, there. It's just now it'll run it properly, but anyway, this is a program that I've made by myself before, and I'm going to be showing you how to make this. And for now the program is fairly simple, it's just a triangle that rotates, but trust me, this is the starting knowledge to create some awesome stuff. A lot more awesome, trust me. You'll see how much more awesome at the end of the video, because I'll show you something I've been working on myself. So, shall we begin? Well, firstly, I just want to say OpenGL is a graphics system designed to work with hardware, and it's really freaking awesome. It's that and DirectX are used to make basically every single game ever, and all the awesome graphics within. So, you know, it'll be quite powerful to have this knowledge. And I just want to say as well that I'm using SDL along with it, which kind of wraps around it a bit. But of course you might be using other stuff, but don't worry, I'm not going to go into the details of SDL too much. And for now I've included these classes. I've included the math class, I've included SDL and SDL underscore OpenGL. If you're using Glut or something like that, that'll have its own separate things. But then also, I've also included IOStream, and you'll also need to include gl/gl.h and gl/glu.h. GL is like the main OpenGL stuff. GLU is it's kind of utilities that are alongside it. But we're gonna be, well, sort of using one. But anyway, if I just get to my cheat sheet, firstly we need an int. We need an int main, and I'm just gonna put the arguments in here. Int args, and a char pointer of an array argv. So this is main. Now the bits in here are mostly SDL stuff, so I'm just going to pause this and insert them in right now, so I'll see you in just a second. And back. That didn't take long to copy. It's quite simple really. Firstly I initialize SDL, then I use SDL's set attribute, which basically sets certain things to do with OpenGL. And first I set the multi-sample buffers to 1 and then multi-sample samples to 8. What this does is it enables multi-sample based anti-aliasing, and what that does is it removes jagged edges. This level is how smooth the result will be, and different people's computers can handle different amounts, but mine can handle up to 8. Although I might actually reduce it right down to 2, because although it makes it jagged edges, because I'm using Bandicam here, it does slow it down a bit when I'm using a lot of my power. So yeah, then it initializes a screen, 640 by 480. And it's an OpenGL screen. It's also 32-bit, but you don't need to worry about that. Then there's this variable, and then it's basically just a timer thing. And I might just, for now, I might just triple comment these functions out because we haven't created them yet. We'll create them in just a second. And now, okay. So first things first, we're going to create a void init. This is the initializing function, which is right here, so I might as well uncomment it just 2 seconds after I comment it. I'll also mention at the bottom SDL GL swap buffers. I'll mention that more in a minute. That needs to be in there, or whatever your equivalent is needs to be in there. So void init. So what do you put in the init function? Well, firstly you need to GL enable several things. This basically allows the OpenGL system to use these certain things. There's also an equivalent GL disable with the same arguments. But first I'm going to enable multi-sampling, which is related to anti-aliasing again. It's useful to have enabled. Then go GL enable GL depth test. That basically, I'll show you what that does in Paint. Don't worry about that yet. But, say I had 2 rectangles And hold on. What does that do? That just draws an outline. That's rubbish. Okay, if I make it alpha, hold on, solid colour. There you go. So say I had one rectangle and that was in front of a second rectangle, which is this yucky green colour. If I draw that one first and then draw the yucky green one here, I know it's got the outline on, don't worry. Then, in fact, I might just no outline. Then, if you draw that one first, that will get drawn to the system. Then this one will get drawn to the system, and this one will be behind. However, if you enable depth testing, it won't do that. It will actually draw them in the right order, because depth testing is quite cool. And let me just. That's better. So yeah, that's what depth testing does. And next up, shall I enable? I might just do something else, because if you try to experiment, you might want this. One more GL enable is GL_blend. This is basically about transparency. And if you're going to use transparency or alpha channel or stuff like that, you'll need it. You also need to use GL blend func. So basically, you need to set this to GL src alpha and GL R1 minus source alpha. So what does that do? I might just go into Paint again and show you. But basically, alpha is a unit of transparency. 1 equals opaque, and 0, and I don't think this really supports transparency because Microsoft Paint is rubbish. But yeah, 1 is completely. No, I don't want to save it, doofus. But 1 is completely opaque. 0 is completely transparent, and you won't be able to see anything. But basically, if I've got an object here with an alpha of say 0.7, what it does is if I've got the background, if I've got the screen background here, all around, then basically it'll show the brightness of that colour times 0.7 plus the brightness of the plus the colour of the background times something else. But 0.7 is the source alpha. So you draw that object with the source alpha, and you draw that with 1 minus the source alpha, because 1 minus 0.7 equals 0.3 if I can write it properly. And you know, when you add those two together, they make 1. So it's complicated, but that's how it works. And then after enabling alpha transparency, I'm then going to go to GL clear color, and then basically we've got red, green, blue, and alpha. As I've said a moment ago, or maybe I haven't, alpha's transparency. But for now I'm going to set it to black, so that's Z. It's all done by mixing red, green, and blue light. So if I have 0 red, 0 green, and 0 blue, then you've got 0 colour, but I'll have 1 for alpha. And if I just... Right, let me just show you something really quick again. If I've got a pixel, here, for now, this pixel stores a colour. It stores a red value, a green value, a blue value, and an alpha value. Now you'll see a function later called GL clear, and when you clear this stuff out, it'll clear it to the default colour. So if the default colour is 0, 1, 0, 1, that corresponds to pure green. So basically, that pixel will become solid green, and that's not very good art. So that's what that does. GL clear color. And then next thing we need to do is get into matrices, and I'm afraid I'm going to have to explain these to you as well. So GL matrix mode, GL projection. This is the projection matrix. What's a matrix, you may ask? A matrix is basically a set of numbers, and the projection matrix is actually a 4x4 grid of numbers, essentially. At its most basic. They're really weird mathematically. But say I had like 1, 1, 1, 1, 0, 0, 0, 0. I don't know. Am I even doing this right? I'm not. Oh well, but it's a 4x4 group of numbers. Basically, 1, 1, 1, 1. Hold on, I want to get this right. 0, 0, 0, and then 3 zeros here. 0 there, 0 there, 0 there, 0 there, 0, 0. So it's a group of numbers. That technically is an identity matrix. It's basically the equivalent of the number 1. You multiply anything by the identity, you just get 1. Well, you just get the original. But that's not important, but basically the projection matrix, it's used to convert from something called I think is it? I can't remember quite what it is now, but it's basically what creates the 3D view. It's what holds information such as the field of view, aspect ratio, and near and far, and stuff like that. But you'll know about that in about 2 seconds. But now I'll admit I've had some troubles with the function that we're going to use, which is called GLU, perspective. I've had some troubles getting it working. But let's just see if it works really quick. Field of view is 45. Aspect ratio is so field of view is just the field of view of the 3D viewpoint. The aspect ratio is basically the width divided by the height of view, and since the width is 640 and the height is 480, that one is the equivalent of that division. The Z near I'm going to set to 0.1, and the Z far I'm going to set to 5,000. That's basically, the Z near is the nearest point that it will draw. The Z far is the furthest point from the camera it will draw. And the further away that is, or the nearer that is, the worse the depth testing will work when you start using it. It'll cause something called Z-fighting, where it just flickers, and it looks really horrible. But yeah, that's that explained, and let's see if this works, just quick, because I've always had problems with it in the past. Now let's let this compile, just give it a minute. And well, I'll be blown, it compiled. Now here's some code, I'll just show you. I'll put it up as a little extra function really quick, in case it doesn't work. But this can be used if you can't get that one to work. This is some code I found on the internet which basically just does the job for you. And it uses the built-in GL frustum, because basically the view is basically done in a frustum shape. And what's a frustum, you may ask? A frustum's kind of a pyramid without the end. So it's kind of like that. I don't know, I can't really draw it, but it's... Yeah, I'm not an artist, in case you can't tell. But it's kind of a pyramid with the end sawn off. And that bit where the end's sawn off is basically meant to be the screen. But anyway, so that's that setup. And the projection there's two matrices used in default OpenGL. We'll use some more later on, because we'll have to replace them, because this is all actually outdated OpenGL stuff, and I'll end up replacing it. I'll show you how to replace it later, but that's going to take way too long, and it'd be basically a 2-hour tutorial, and you're not going to want that to draw a simple triangle, are you? So for now we're just using the old code. But there's two matrices, the projection one which does the perspective stuff, and it also works for 2D orthographic view. And then there is also another matrix which we're about to use now, which is the model view matrix. Model view matrix is basically how you rotate and translate an object by, and scale it as well. Oh, and something I forgot to do here. GL load identity. That resets the matrix. Remember I said about the identity matrix, where if you multiply anything by it, it makes 1. It's basically that. It's that matrix. And I've loaded identity down here as well. I'm not going to do anything with the model view matrix for now. That'll be done in the display function, which as you can see we haven't created yet. So, what else is there to do? I'll tell you what else. There's the display function. Next. Display. So, what's the display function? This is the function that runs once every 60th of a second. So 60 times a second. It's called inside this function, which is using the frame thing. So it runs once per frame. It's a frame timer thing, which I set up in SDL. This code, full credit to the C++ guy. This C++ guy, by the way, I kind of copied this off him because I never really learned SDL. But yeah, that's his code, but this is mine. Well, it's all based off this one actually, to an extent. But yeah, it's all similar because it's OpenGL and everyone's code's similar really. But then let's see. So the first thing we're going to do is the clear function. I think I briefly told you about the GL clear function, but we're going to clear the GL color buffer bit and the GL underscore and the GL depth buffer bit. Now, what are the buffers? Well, complicated, I suppose. But basically, to explain it a bit, each pixel doesn't just store a color value. It does store color, and it stores it in 4 points. It stores it in red, so it stores it in red, green, blue, and alpha. So that would be a red color. So it stores the color values, but it can also store depth values between 0 and 1, which are based on how close it is to the near or the far plane, which you set in GLU perspective earlier. So it can store the depth values, which is how depth testing works basically. It will only overwrite if the depth value is less than the value that's already there. That's how it works. But you've got the depth value, so say 0.5, and then there are also other ones. So that's the depth buffer, and that's the color buffer. So you've got the accumulation buffer, which basically accumulates values as you render and render and render more things to it, which I'm not getting into, but it's used for all sorts of things. And then there's the stencil buffer, which used to be used for things like reflections, but basically, if you store a value of 1 in there, it will draw to that pixel, but if you store a value of 0, it won't draw. Store a value of 0.5, and I don't know, it'll half draw. I don't know, I've never really used the stencil buffer for anything. I don't get it, and to test anything you can do in stencil, you can do in shaders. But you'll see more of that later. So you clear the buffers. Load identity again. For now, we're just assuming. I'm not going to change it back to projection for now, but you can. In future, you could change back. You could change to the projection. Set it to GL ortho, which is basically 2D. So use a 2D view. Draw an overlay and then go back to projection. Or something like that. But for now, we're just going to do it like this. So GL load identity. And then next we're going to do GL translate F. And then what does that do? That will basically move anything that's drawn from now on. And this is one of the things that's done in model view matrix. Translation, it also does rotation and scale, but it'll basically move anything you draw to a new position. So I'm going to translate it by 0 in X, 0 in Y, and -5 in Z. Now I just want to make something clear really quick. That, hold on, if it'll draw. But if you have a set of axes, the X goes that way. I'm sure you're all familiar with that. And then the Y goes that way. But which way does the Z go? That's something you'll have to get used to. It goes. So this is increasing X and this is increasing Y, but increasing Z is as you move closer to the camera. So -5 is going to move it in that direction. So yeah. So that's just cleared that mystery up. And then after that, I'm going to go and I'm now going to draw something. So you're actually going to see something on the screen. So I'm going to GL begin GL underscore triangles. Hold on. There. GL triangles. I'm also going to GL end. It's basically telling it that it's drawing. It basically tells the system, okay, anything you draw between this begin and the next end will be triangles. And basically, every three you'll draw out vertices and basically positions in the 3D space. So like there, there, and there. But every three vertices, it will join the dots and create a triangle. When using triangles, there's also things like quads, which is 1, 2, 3, 4, and then join them up. There's triangle fan where you kind of draw a central one, then you draw points around it, and it kind of does that, 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 and then joins those lines. There's also triangle strip where you draw that, 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 and it sort of kind of does that as well. And it looks like half a Christmas tree. But yeah, that's that. There's other shapes as well. There's lines, points, and all sorts. But for now, we're using triangles. So GL vertex 3. Hold on. So now I've got to supply these vertices. We're going to do it by GL vertex 3F. I might just tab that up there. Now GL vertex 3F is simply asking for an X, a Y, and a Z. Easy enough. And I'm going to supply it with a 0 in X, a 2 in Y, and a 0 in Z. The next one is going to be -2 in Y and a -2 in X. You'll see why I'm leaving the space in a minute. And then the next one is going to be a 2 and a -2. So now, congratulations, you have successfully drawn triangles. Or a triangle anyway. Da-da-da! Here is the beautiful triangle. And now you're probably moaning at me because we've just spent 22 minutes and 39 seconds drawing a white triangle. Now trust me, it's worth doing. Because once you've got drawing triangles done, there's a lot more you can learn to do. And now I'm going to show you the first thing I'm going to do, which is colours. Now colours are easy, and this is also why I left the space, because now I can go to GL colour 3F, and it's asking for a red, a green, and blue. You can also use 4F, which has an alpha. I might actually use 4F today because I feel like it. Now I'm going to do one, and basically it'll always set the colour to the vertex after. So if I set this one to 1, 0, 0, 1, which corresponds to red, then it will set. You'll basically be red. Red will go to this one, and then any vertex after until I do another colour 4F call, which I'm going to do right now. GL colour 4F 0, 1. So now it'll be green because I've just put 1 on the green and taken 1 off the red. And for the record, with alpha, if in doubt, use 1. If you really need to use alpha, otherwise, I mean, you could just use GL colour 3F. But yeah, I like showing off. So yeah, if it wouldn't mind actually compiling. All right, it's still doing something. Now, what's the matter with it? Hold on, let me just sort this out. Sorry about that, the IDE started messing about and wouldn't let me compile. Made it look as though it thought something was running when it wasn't. But anyway, now if I run it, as you can see, the triangle's coloured. And what's more, it actually interpolates the colours between the vertices, meaning that it will blend between them. And that just makes some beautiful colours. And it's quite cool. But now you're thinking, well, this seems a bit stationary, isn't it? Which makes it a bit rubbish, doesn't it? You know, it's not even moving, it's just a stationary triangle. Well, no matter, because this is where the update function comes in. Oops, hold on. Let's see. This is probably one of the last things I'll do for now. Void update. And I'm also going to create int. I'm going to create an integer called frame, which I'm going to set to 0. Now this is really simple. It's literally going to be a number that goes up every single frame. And now, let's see. Now I'm going to rotate my object. I am going to call GL rotate F. Now rotation isn't as simple as you'd think. It's done in a weird way. Because first you supply the angle, then you have to supply an X, or Y, and a Z coordinate. Now what does this mean? Well, I'll show you. I think it's something like quaternion angles or something like that, but I can't remember. So you've got your X, you've got your Y, you've got your Z. If you say it to 0, 1, 0, then that means all the rotation will be on the Y-axis. So basically what that means is that it's going to rotate around that point, this shape. Say the shape's here, for the fun. It's going to rotate around that point. And then in the X-axis, if I say it to 1, 0, 0, say it was all in the X-axis, it would rotate around that axis. It wouldn't be around the point, it'd be around the axis, but anyway. Then if you did it around the Z-axis, say it to 0, 0, 1, not 0, 0, 7 though, because that's James Bond. Anyway, say it to 0, 0, 1, and you're going around that axis. But say I set it to no, not 1, 0.5. It would work for 1 as well, but 0.50. What would that do? That basically means half in X, half in Y. So that would basically work as they've got another axis there, and it would rotate around that. If you get me. So you're basically supplying an axis with those 3 coordinates. But so yeah. But the first argument's the actual angle itself, and for now I'm going to make that angle equal to the frame. You can also multiply it by, say, 2 to make it twice as fast, or divide it by 2 to make it half as fast, or something like that. And then you supply the axis, and I'm going to do it around the y-axis, that's 0, 1, 0. And then compile, and run. And enjoy your mesmerizing spinning triangle. And give yourself a round of applause, because you've just now learnt to use some of the best graphics hardware of all. Or at least you've started to learn how to. You can't really go around calling yourself a pro yet, there's still a lot to do. But yeah, I might just set it to FrameStar 2, just to speed it up a bit for now. Don't worry, we're going to get a lot done in this tutorial series. So yeah, now you've got a coloured triangle. I'm just going to show you something that I've been working on. If I just go into open, here it is. It's this program. I might have to slightly edit it in the space of about 2 seconds. Come on, hurry up! Hurry up! Okay, now it's just fudging up for a moment then. Okay, so now I've got this project. This is something I've been working on. Don't get yourself bogged down by it. But some of the code is stuff that we've already done. Other bits are very different. Very, very, very different. Just don't get yourself bogged down. I'm just trying to find a piece of code that I need to quickly change. In fact, I might just change 2 pieces. First, I'm going to remove that full screen flag because Bandicam doesn't seem to like me working in full screen. Then I'm going to set the resolution to 1280, 720. So basically this will now run at 1280 by 720p. And compile. Keep compiling. Okay, you're nearly done compiling yet. But this is something I've been working on. Because I've been experimenting with stuff like normal mapping and stuff like that, which is shader based, and you might have seen it in modern video games, but it's a cool effect. And let's see if it'll run properly. Yeah, it does. Hold on. See if I just take it over here so you can see it all. Welcome to my world. I apologise for the glitchy triangle at the bottom. I do not know why that happens at the moment. But yeah, I've basically created a world. It's the next tutorial I'm going to be showing you how to do textures, so I'll be able to have these, so I'll be able to have scenery like these rocks, which I did not draw, by the way. They were done by someone else. Lighting will come another day, and so will this normal mapping. And also I can move the light around by pressing space repeatedly. And if I put it down here, get to the right angle, you can see it. You can see shininess to it as well. But yeah, this is just something I've been working on, and by the end of this series you'll be able to do this too. And what's more, you'll probably be able to do it even better. Oh, and another thing I can do as well is load 3D models. And that's something which will come quite soon. Well, the problem is that one of the challenges with this at the minute is that at some point we're going to have to replace a lot of the code that we've done. Because a lot of it is out of date and not as effective. I mean, look at this. This is where I do the equivalent of the matrix stuff we've done already. This is just modified though. This is... I basically had to remake it. I'll show you how to do it all in good time. So, anyway, sorry if I scared you a bit there. But yeah, trust me, it will all make sense in good time. Thanks for watching. Please subscribe. Please keep watching this series. There's plenty more for me to do. And indeed, please do subscribe, because you know, you'll be able to see this series then. You'll be able to know when the next one's... You'll be able to know when I release the next one, which might actually be tomorrow. That'd be good. So yeah, thank you for watching, and next time it's probably going to be maybe textures if I feel like it. Maybe, just maybe shaders, I don't know. So yeah, I'll see you next time.